All right, so let me share my screen, and then I'm going to open Eclipse, and then we can get started. Can you guys see my screen?
Yes.
Perfect. Okay, so let me start Eclipse. So Hannah, I don't think you were. Did you watch the last session on YouTube?
Yeah.
Okay, so you're familiar with just like basic syntax for Java and like
Yeah.
and stuff like that. Okay, cool. So yeah, if you want to follow along on your computer and just listen to me, that's fine. Or if you want to watch as I'm typing, whatever you feel comfortable with.
Okay, cool.
All right, let me know when you're ready.
Hey, go for it, Pratik.
Okay. Yeah. So I'm gonna close the old code. Basically what object-oriented programming is it's making a template and then allowing you to basically use that template in different scenarios. Think of it so instead of writing a lot of code, and this is kind of very similar to what I talked about in the last session, where if you have something that's repetitive, it's a lot easier to write it into a function and then just call the function different times. So that same principle, when you expand it to like a larger scope, is an object and a class. So what we call the class is like the template or like the stamp. You put in effort writing one set of code, and then when you want to use it in different places, you can make different objects, which is like an instance or like a version of that template. So what can be an object? Like in code, anything, and the best way to think about this is any noun can pretty much be an object. So the way we do it for the robot code is we have the robot itself isn't an object, but each of our subsystems is an object. So we have our drivetrain, our intake, and like depending on the game, we have like a shooter, or maybe a hanger. And the reason we do that is because we can write all of the code to control all of those various things once, and then when we need to use it in the teleop mode or the different autonomous modes, we can just call an instance of that and make a version of that to then use locally instead of copying and pasting that huge blob of code, because we don't want to have to write like the very specific details of like which Talon or which like Victor we want to control and like what speed we want to run it. We just want to be able to say like intake dot set speed, and then it can do all of that. So today we're going to go ahead and do two exercises. The first is just going to be making a simple object, and the way you do that is you're going to right click on the default package and you're going to hit new class. You can also go up to file and hit new class. So in the name space here, we're going to call what we want our class to be. So I'm going to go ahead and write student. So what do we want here? Let's go ahead and add a main just so we can test it, make sure it works. And that should be it. We can go ahead and hit finish, and it's going to spit out some generic class template that it has that's super empty. So here we have public class student, and then we have our main function. So I'm going to go ahead and move this down a lot just so we have some room. So what are some inherent things, like features, values that a student has?
Hair. Great.
Grade. Okay, that's good. So what grade they're in? So we can make that an integer, right? Because it's not going to be any non-whole number. So let's go ahead and write int grade, and we're just going to put a semicolon there. So before the int though, we're going to write pub. Let's go ahead and write private, and I'm going to explain what that means in a second. So what else is there inherent to a student?
Homework.
Uh, you can say like has homework.
Yeah.
So let's write that as public boolean because it's just a yes or no. Has homework. So what about a student ID number?
Sure.
The private int ID. And let's add one more. Trying to think.
They have a name.
Yeah, that's a good one. Name. Good job. Good job. So that's going to be a string because it's going to be a series of letters, and we're going to make that public. So here I have various public and private values. So all of these are variables that are inherent to the student. So anytime I make a student object, all of them are going to have their own individual grade, has homework, ID, and name. What private and public here means is whether it can be accessed from outside of the class. So down here in the main, it's not in the class. If I make a student object in the main and I were to try to access grade, it wouldn't exist. But if I try to access has homework, it would, because that's the difference between private and public. When it's private, it can only be accessed within the student, and only students' own functions and methods can access that variable. So let's go ahead and make a constructor. So a constructor is something that you need for every object, and it basically tells the program how to make your object. So the way that you do that is you write public student, and if you want to pass in any variables, you can. So let's go ahead and make it so that you can pass in the grade, homework, and let's go ahead and assume that the name gets set later. And let's just write public in. Yeah, let's just go ahead with these two. So note that you don't actually have to make these set to anything, because you can set those later explicitly or implicitly. This is an explicit constructor because we're saying that this is their grade and this is whether they have homework or not. So down here we're going to go ahead and we're going to set these inherent values of the object to whatever we're inputting from the outside. So we're going to say grade equals input grade. And we're going to say has homework equals input homework. And just note that these, for obvious reasons, should be called different things. Otherwise, it'll try to set its variable to itself, which won't do what you want it to do. So now that we have our student, let's try to give it a name. Obviously, we haven't given it a name yet. So we're going to write a function called setName. So we're going to go ahead and write public void setName, and we're going to input the name. And we're just going to write name equals in name. And we're going to go ahead and do the same thing. We can pretty much just copy and paste this for the ID. So, but instead of set name, we're going to write set ID. And then here we're going to change this to an int, and then this should be in ID. Cool. So now we have different ways to, make a student object, and then we can set the name explicitly, and then we can set the ID. But how do you use a student object? So maybe we can add some more fields. Let's add a current grade field. So that should be, let's just do it in decimal, so that'll be
Why don't we call it like GPA instead of grade?
That's good. Yeah, we can do that. So let's make it private. Private double GPA. So let's go ahead. Yeah, so notice that I made it private. Again, that means that we can only access it from the outside. We can't, inherently do whatever. We can't, just access it and change it from the main. We can only read it if we have a function that reads it. So let's go ahead and make that public. So I'm going to make a function that just returns the GPA. Double get GPA. So that allows the main, or any code that's in the main, to access the inherent GPA here. So let's go ahead and add some grades, or make a function to at least add grades.
Oh, he's gone.
Oh, he's actually not.
Petite, come back. No.
Yeah, so I'm not really sure what happened there.
Oh my god.
Oh my god.
So is it working?
Yeah.
So what part did I like not add?
You were writing the. Actually, hold on. I can't see this thing. Wait a second. No, you were like in the middle of writing the return GPA function.
Okay, so
Oh, you're
okay,
adding stuff. Yeah. There you go.
yeah, so basically like this function that I wrote just returns a GPA to the outside, whether that's the main or some other function or whatever. And I made this to add a grade to the GPA, and I made some, arbitrary calculation that it just adds the grade to the current GPA. I know that's not how GPAs work in real life, but just for the sake of this example, that's how we're going to do it. And then what I did is I came down here into our main, and I started making our, our object, our singular instance of the class that we wrote above. And the way you do that is you do the class name, the name of your object equals new keyword, because that's like physically stamping and making a new version of the object. And then we do the class name, and remember up here in our constructor, we had an input of the grade and an input of the homework. So down here, we're going to write the grade and then whether they have homework. So this is a freshman that does have homework. And we're going to go ahead and give that freshman a name. So we're going to say example student. And then the way we access all of these functions is we write dot. And note that Eclipse will actually like come up and give you some examples and some suggestions. So we're going to go ahead and set their name. So what's a suggested name?
Fred.
Fred. Okay, cool. So now if I were to, try to access the name of the student, so let's go ahead and do that. Let's just do sysout. And we can do this because the string name here is public. So let's do example student.name. Go ahead and print that. I'm going to save this and run it. And as you can see down here in the console, Fred was printed because the student's name is Fred. Cool. All right, so let's go ahead and give Fred some grades. Let's just say example add grade, and let's give him, an A. Maybe we can copy and paste this a couple of times and give him, maybe he gets a B, he gets another A, and then let's make him fail a class or get a D or whatever.
Poor Fred.
So, and now what we want to do is at the end we want to print out his grades. So we get system.out.println, and then we do example student get GPA. So save that. Let's run it, and it says 12. Is that correct? It was 4. Yeah, that's 12. Cool. So something to note here that was actually very bad programming in general. Whenever we created our object, GPA was never explicitly set to a default value. So note that when we create in our constructor, we have a couple of fields that are missing. We have ID, name, GPA that are missing. So good programming practice is to go in here and say that ID equals or name equals empty string, and then maybe GPA equals 0. Just because that'll make it so that there's no way that this can error out or maybe do something that you don't want it to do. So this is basically a super simple overview of how to make an object. So later on, maybe in programming sessions, we're going to go ahead and make our own subsystem. So the way we do that is we'll make a different object for our subsystem, and then we're going to go ahead and have different vectors and stuff like that. But the basic process is extremely similar. You make different inherent values that are specific to the subsystem. You have a way to create the subsystem, and then you have different functions to modify the subsystem. All right, cool. So now let's go ahead and make a new class, and then we're going to call this a bank account. So we're going to make a new class. We're going to call this bank account. And we're going to add a name. And you can go ahead and close it if you are using another one. If you're just following me, then just do whatever. So what are some inherent features of a bank account? Obviously, the amount of money in it. So we're going to write that as a double current balance. And we're going to make that private. We don't want anyone else to be able to see that unless we explicitly say you're allowed to see that. What else is there? There's going to be a name on the account, so we're going to write that as a private string name. And
there's the bank it's with.
What was that?
Oh, there's the bank it's with, but I don't think that's...
Well, yeah, I mean,
yeah,
we could do that if we want, so let's just do that. So this is just a super simple, super generic version of a bank account. So what we're going to do is we're going to, make, how do we construct a bank account? So we write public bank account, and then we're going to assume that the current balance is going to be 0, and we're just going to log the name of the bank. So string in name and string in bank. Name equals in name, bank equals in bank, and then we're going to assume the balance is 0. So we're going to write current balance equals 0. 0.0 just because it's a double. All right, cool. So what can you do with a bank account? You can obviously withdraw, you can deposit, and that's pretty much it. But I guess you can also, view balance. So we'll make those three functions. So we're going to write public withdraw. That's how you spell it. And we're going to write double amount.
It doesn't have an L.
Cool, thanks. So we're going to withdraw, and it wants here. So we're going to say void. Just because we don't want to return anything. So how do we do this? So something inherent to withdrawal is you obviously don't want to, over withdraw. You can only withdraw however much you have. So let's say if current balance minus amount is less than 0, then we're going to say return just because we want nothing to happen. Else, so this means that we're allowed to, withdraw the balance, then we're going to say current equals current balance minus amount. That'll withdraw however much amount, and it'll also make sure we don't go below 0. So let's make another function to deposit. Public deposit. And then we're also going to have double.
You spelled public wrong. Oh, there he goes. Bye, Pratik. Should I at him? Pratik, you're gone again. Oh my God.
Yeah, I'm not really sure why that's happening. Okay, well, regardless. So for our deposit, we want to make sure that the amount is positive, so they don't try to deposit a negative amount. So the way we do that is if amount is greater, then we're going to say that current balance and then else it's nothing's going to happen. Actually, I'm going to clean this up by doing this. The current balance is greater than 0, and then we're just going to write this in here, and then we can just get rid of the else. Basically, the withdrawal, make sure that you don't go below 0, and the deposit, make sure that you're depositing a positive amount, and then we're going to write public view balance. So this is going to return a double view balance. Cool. So now down here, we're going to make our bank account. So let's just stick with Fred for whatever reason. Say that, new, I'm going to say Fred. Just call this, first. So what can we do? So let's go ahead and current, print whatever Fred's current balance is. So it's going to be example.
Pratik, your audio keeps cutting out.
Can you hear me now?
Yeah, I just was able to hear you.
Interesting. Yeah, I'm not exactly sure why that's happening. The only device that is on the Wi-Fi is my computer. Okay, but yeah, so we're gonna, print our current balance just to demonstrate. So let's go ahead and run that. You say current balance equals 0. So now let's go ahead and deposit maybe $1,000. So the way we do that is example. We're gonna write 1,000, and then we're gonna, print current balance again.
Your mic keeps muting itself, Pratik. Like, it's not even that we can't hear you. It's just like the mute symbol goes up.
That is very odd. Yeah, I have no idea. Okay, well, I guess I'll keep continuing and you'll tell me if there's an issue. So we're going to print a deposit, and then we're also going to withdraw some money. So the way we do that is example account withdraw, and let's withdraw, $20.57. Then we're going to print the final balance after. Let's run that. So starts with 0, you add the $1,000, and then he withdraws $20.57. So all of that works perfectly. Cool. So now we're going to make another class, and we can actually do this in the same file. It's not good practice, but the reason I'm doing that is because we have our dedicated main here. So basically, like, if you look at the way the curly braces act, this first curly brace closes with this last one, and that encapsulates one class. So if we want to make another class, we can go outside of that. So down here, we can start over. We can say public, and this one we're going to make a savings account. So public class savings. And we're going to basically, instead of rewriting the different withdrawal, deposit, and view balance and all that other stuff, we're going to write basically a class that extends from bank account. So a savings account is a type of bank account, but it has some specific nuances, right? It accumulates interest, and that's pretty much the only difference between a savings account and a regular account. So we're going to go ahead and write public class savings account. We're going to write extends, and then we're going to say it extends bank account. Add our curly braces. Let us do this. No, I was just going to, okay. So basically what this extends bank account allows us to do is we don't have to rewrite all of the functions that exist within bank account. Since we're extending it, it's going to assume that if I have a savings account object and I try to deposit, it's going to assume to use the initial bank account's deposit unless I have a function within savings account that does something different. So we're gonna write one example of that, and then we're just gonna add a different different interest function. So for this constructor, we're gonna make one. So we're gonna write public savings account. We're going to still pass in our name. Do is we're going to just write super, which basically means it's going to use the bank accounts constructor, and then we're just going to put in name, comma, in bank. What's going to happen is if I try to make a new savings, why is this? Oh, I guess I do have to make this in its own file. Or maybe, does that work? Cool. Okay, never mind, I lied. So basically, yeah, so like I was saying, if I try to make a new savings account object, I'm going to still pass in the name of the account and the name of the bank, and then what's going to happen is it's going to immediately just shoot that over to the initial bank account constructor and then create a new bank account. So it's basically wrapping bank account around within like the savings account structure. So like I said, we're going to make a function. It just says public. We're just going to say, add interest. And the way we're going to do this, let's void.
You spelled void wrong.
call. So the way we're going to do this is we're going to say int balance. View balance. We don't technically need to do, but we're going to say, interest, or we're going to make tables, sorry, because it's money. Let's give it a generous 5%, 0.05 times the.
Pratik, why? Hi again, Pratik.
This is so odd. I honestly have no idea why this is happening. Yeah, I can't really, see any settings or anything that would make it, just like straight up drop out. So I'm not really sure what's happening.
Huh.
Whatever. Again, I'll just keep continuing until it's like an issue. So yeah, let's see, where were we? Cool. So yeah, we added our add interest function. We were looking there. So we calculated our current interest, and then we're going to deposit that interest back into our account. So we're going to say this interest. And then it's basically, again, it just calculates how much interest it owes and then just deposits it back in. So now we're going to add a different withdrawal function. And the way we do that is we write public. Let's just do again, void withdraw. The reason we're making a different one here is we're going to say that every time we withdraw, there's going to be a 3, maybe not 3, there's going to be a 1%, exchange fee or withdrawal fee, there, added there. So we're going to write this dot with 1.01 times amount. And again, that's just adding 1% to the amount that's being withdrawn. So that 1% would then, in theory, go to the bank, and then the rest of the amount would go to whoever's doing the withdrawal. So this is all we need to do to make a fully functioning savings account. We don't need to reinvent the wheel and rewrite a bank account, because we can just go over here and write extends bank account. So we are going to go ahead and instantiate that here. So instead of current balance, we're just going to call this bank balance. To show that this is like an explicit bank account example. And now we're going to go ahead and let's go ahead and make our savings account. And use example account 2. So why is it angry? Hold on. No one closing this. It's probably just because I need to,
Yeah, you were.
file. So I'm just going to go ahead and make its own file. So class, and then we're just going to call it saving. We don't need to add a main. We can just hit finish, then control, and I'll just paste that all in and save it. Cool. All right, cool. So there's no error. So right now we have our example account. It's just a straight bank account, and we're going to make this saving. Account 2 is going to be a savings account. So again, this is starting with 0, depositing 1,000, and then withdrawing. So let's do the same thing, except we're going to add interest in between all the steps just to prove that it starts at a different value. So we're going to just go ahead and copy these. We're going to start this with savings balance, and then we're going to deposit 1,000, and we'll do that to the second account. Second account. And then we're going to go ahead and we're going to add different steps to the way. So print the balance up to that, and then we're just going to withdraw the same amount. And we're going to also and we're going to print. Yeah, perfect. So let's go ahead and save and run this. Oh, let's change these to savings. Sorry. So when we run it, there's lots of errors. Stack Overflow, what? Yeah, not exactly sure what that is. So there's a static, 10 cents charge to withdraw something. Maybe I don't know why that would, be an issue. Oh, nope, that's still an issue. So let's go ahead and not include a withdrawal fee. So, basically, if we just delete that, it's going to use the inherent withdrawal. Okay, so yeah, so again, the bank balance starts at 0. We deposited $1,000, and then we withdrew $20.57 to end up with $979. So in the savings account, we deposited $1,000, we added interest, and then we withdrew $20.57, and then we added interest again, and we ended up with almost $100 more. But basically, this is just an example to show you how you don't have to reinvent the wheel every time that you make a new object. So the way we do it is we have a pretty sparse generic subsystem class. Maybe I can show you that. Let's go ahead and show that. So this is our code from 2016. It's going to be riddled with GitHub conflicts just because there's some conflicting code issues, but basically, we're going to go ahead into source, not the reference libraries, and this, again, we have a very structured system, but all of these different packages represent different parts of our code. We have utilities, all our subsystems, which is where we're going to go into, loops, file I/O for how we write new autonomous modes, and then this is where we store all of our autonomous modes, and then this generic class is where we have our actual where the quote-unquote main of our project is. So let's go ahead into subsystems. So from our last year's robot, we had a drive, we had an intake, a shooter, but this function right here is the generic one that I was talking about. So this is our generic G3 subsystem, and basically it's, again, as this documentation says, it's a base class or a subsystem. It's a subsystem is a mechanism or a cohesive function of a robot. Examples could be drive, arm, shooter, intake, etc., etc. So what it does is it has some super simplified, super generic functionality to have different controllers set to it. It has its own open loop set, and all of these can be overwritten into the specific subsystem. So a super simple subsystem is our intake. So again, up here, our intake extends the G3 subsystem. So this comment is obviously legacy copy and paste code, but so what do we have? We have some inherent parts of the intake. So we have a Victor, a solenoid, and some variables. And there's some room for sensors, but our intake didn't have sensors. This is our constructor, and what it does is, you set the Victor to the correct PWM port, you set the piston to the correct solenoid ports on the RoboRio, and then we have our various functions to set the speed of the intake, to raise it, to lower it, to determine if it's up. And what this allows us to do is, if we were to go into any of our different autonomous modes, so let's say, let's just say run intake. Instead of saying that I want to, write the exact PWM port to a certain speed, I can just say mintake.set 0.0. And that's because, somewhere else I just made an intake, actually in state up here. It's another example. This is a very generic top-level class, and I have one singular version of the drivetrain. I have one singular version of the intake, one singular version of the shooter, and then all of these different, sub-states use that version, so that it takes this intake, and then you just have to write intake.set speed or whatever. So that's basically a super brief overview on object-oriented programming. Obviously, I'm skipping a lot of stuff, and if you want to learn more about it, just let me know. I can send you links to, actual Java teaching classes on Code Academy or Udacity or something, where you can learn more and delve into the, intricacies of how to, program Java classes. Not that you might want to, but I mean, if you're just taking this class or watching this video to learn how to program the robot, what I showed you in this video is pretty much all you need to know. Sorry. So yeah, for our next class, I'm guessing it's going to be 1 week from now, if people show up. It's going to be our first foray into programming a robot. It'll be really quick because you can program a robot with pretty much 10 lines of code. So we're just going to do the super simple stuff, and if that gets over quickly, we can start going into more advanced stuff. So yeah, that's pretty much it. Thank you guys for coming. I will post all of this code as text files to the Slack channel, so you guys can feel free to review it later if you want. And that's pretty much it. Thanks for coming.